Okay, dear student, now we will continue our analysis for the concepts about the electricity. We now studying the concept of ohmic resistance. What is the meaning of ohmic resistance? During the passing of the electric charges through the conductor, you will find that the atoms of the metal vibrate. Vibrate means moves, ups and downs. This motion of the atoms up and down will make the atom make collisions with the passing electrons. This collision between the atoms of the wire and the electrons of the electric current, this collision cause opposition for the passing of the electric current. So this opposition is called ohmic resistance. And as the vibration of the atoms increased, of course the ohmic resistance will increase. Why? Due to the collisions between the atoms of the wire and the electrons of the electric charges, or the electric current will increase. So we can define the electric ohmic resistance, or it is the opposition to the flowing of the electric current when it passes in a conductor, or it's the ratio between the potential difference between 2 points on the conductor and the electric current intensity passing through this wire. So we have here something is called R. From here I can tell you about Ohm's law. Ohm's law said to us at constant temperature. This sentence is very, very, very important. At constant temperature. We will discuss this after seconds. At constant temperature, the electric current intensity passing in a conductor directly proportional to the potential difference between its terminals. So I directly proportional to V. Here this means as V increased, I increase. If V decrease, I will decrease. But here the question is, why constant temperature? Constant temperature due to, as the temperature increase or decrease, of course we will study increase and the vice versa decrease. As temperature increase, the vibrational speed of the atoms of the wires will increase, of course, due to the heat energy will convert to kinetic energy. This means the collisions between the atoms of the wire and the charges of the electric current, this collision will increase, of course. By increasing the collision, the ohmic resistance will change. And this opposes the concept of R in Ohm's law. What is the meaning of that? The concept of R in Ohm's law means that V over I equal constant value. This means R equal constant value. This means the rate of collisions between the vibrational atoms and the electric current is constant. So the temperature should be constant too. Due to if the temperature changed, the collision will change and the ohmic resistance will change too, and this is wrong for Ohm's law. Now you know that R equal V over I. This means Ohm equal volt over ampere. So we can here define Ohm. What's the meaning of ohm. Ohm is the resistance. It's the ohmic resistance of a conductor that permits or allows the flow of current. Its intensity 1 ampere. Its intensity 1 ampere. And the potential difference between its terminals equal 1 volt. So ohm equivalent to volt per ampere. Now I want to discuss something very important with you, which is how you can compare between the consumed power between two resistors. I have here BW1 and BW2, and of course I have R1 and R2. The ratio between BW1 and BW2 will change depending on the way of connecting the resistors. You studied before we have two types of connection of the resistors. We have series connection and parallel connection. Series connection means the electric current intensity will be constant. So if I equal constant value, this means BW1 over BW2 had equal I power 2 over R and I power 2 over R. If I constant, so BW1 equal I power 2 over R1. I power 2 R1, sorry. BW1 equal I power 2 R1 and BW2 equal I power 2 R2. So I power 2 in the numerator equal I power 2 in the denominator. So we can cancel these two i's. So remains R2 over R1. Then BW1 over BW2 will equal R2 over R1 if the current intensity is constant. What about the parallel connection? Parallel connection means the resistors are connected on different branches. So V will be constant. If V will be constant, so BW1 will equal V1 power 2 over R1 and BW2 equal V2 power 2 over R2. Here V1 power 2 equal V2 power 2 due to this connection is parallel connection. So we can cancel V's with each other. We will find here BW1 over BW2 will be R2 over R1. R2 over R1. So BW1 over BW2 with series connection, I will be constant and the relation will be R1 over R2. Parallel connection, this means the potential difference is constant, then the relation BW1 over BW2 will be R2 over R1, not R1 over R2. It's R2 over R1. Don't get mixed between these 2 points. Now I want from you to answer this very important question. If I asked you about the factors that affect the ohmic resistance, of course we learned together that the factors we can figure it out from the mathematical rule. Then by depending on this way you can tell me that R equal V over I, then it depends on potential difference and electric current intensity. This is wrong. Take care of this question. R doesn't depend on V and doesn't depend on I. Due to V over I equal constant value, R here constant, so you can't tell me that R equal V over I. So due to R equal constant value here in this part. Okay, so still the question standing. What are the factors that affect the ohmic resistance are? The factors that affect the ohmic resistance are depending on the nature of the ohmic resistance itself. The ohmic resistance is the collision, so any factor that act on the collision is the factor which change the ohmic resistance are. Try to think with me about these factors. Of course, number one is the temperature. The temperature act on the ohmic resistance, we know that. What else? The type of material. If you change the type of material, of course the resistance will change. What else? The length of the wire L. As the length of the wire L change, of course the resistance will change. If you have two conductors, one its length equal meter and the other its length equal 10 meters, the passing of the electric current through the 1 meter, the number of collisions will decrease, of course, comparing with the 10 meters. Due to as the length increase, the number of atoms which make a collision with the electrons of the electric current intensity increase. And as the collision increase, the ohmic resistance increase. So the relation between the ohmic resistance R and the length of the conductor is directly proportional together, so the line will be straight line passing by the original point. So R directly proportional to the length L. Okay, another thing, the cross-sectional area A. If you have two wires, one its cross-section area equal 1 centimeter squared and the another one 2 centimeters squared. As the cross-section area decrease, of course the distance which is covered by the vibrating atoms will decrease. This means the atoms don't take time to move up and down. It's rapidly move to up and rapidly return to down. So as the diameter, the area decrease, the atoms can make a large number of collisions, a lot of collisions with the electrons. So as the cross-section area decrease, of course the collisions between the atoms and the electrons will increase. So the ohmic resistance will increase. But if the cross-section area is very large, it's very big, this means that the vibrating atoms will take time to move up and to return down. This time will make the number of collisions decrease rapidly. So as the cross-section area of the wire increase, the ohmic resistance will decrease due to the number of collisions will decrease. So the relation between R and the cross-section area A is inversely proportional. So we can say that R proportional to L over A. Is this form is equation? It isn't a mathematical equation, of course, but it's called inequality. We need to convert this inequality to mathematical equation. So we'll replace the sign with equal and we will put beside it constant. So R equal constant times L over A. What is this constant? This constant is called resistivity of the conductor, rho E. Resistivity rho E. It's a physical quantity which is constant for the same material. It's called characteristic property of material. What is the meaning of characteristic property? We can recognize the material by using this value. Copper has a specific value. Aluminum has another specific value. Lead has another specific value. So R equal rho E L over A. This rho E is called resistivity. resistivity here equal R times the cross-section area A over L. So of course we can together find its measuring unit. R is measuring unit ohm. As you see here, this symbol is called omega. This symbol is a Latin symbol, a Latin letter. Its sound is omega. A is its measuring unit is meter squared, and length is meter. So we can cancel 1 meter with another meter. So still with us ohm dot meter. It's the measuring unit of resistivity. The measuring unit of resistivity, it's equal ohm dot meter. Okay, and we can here from this law to put a definition for the resistivity. What is the definition of resistivity from this law? Here rho E equal R A over L. So the resistivity is the ohmic resistance of the conductor if its cross-section area equal 1 meter squared and its length equal 1 meter. It's the definition of the resistivity. Here, as you see here, R and 1 over A, the line will be straight line, passes by the original point. This is the resistivity. If I asked you what is the factors that affect the resistivity? Resistivity is constant value. Any constant value depend on only two factors. These two factors doesn't change. Number one, type of material. Number two, temperature of the conductor. Type of material and the temperature of the conductor. If the temperature increased, the vibrational speed will increase and the resistivity will increase, of course. Here, notice this point, rise in temperature of the conductor. As the temperature of the conductor increases, its electric resistance will increase. Due to the rise in temperature increase the amplitude of vibration, as we said, of the metal molecules, and its speed of vibration will increase. So the rate of collision of the electric current electrons with metal molecules, that increase the opposition. Here we have a very important new terminology which is called electric conductivity. What's the meaning of electric conductivity? As you notice here, electric conductivity, it's the opposite of electric resistivity. Its symbol, as you see here, is sigma. This symbol is called sigma. So it's the reciprocal of the resistivity of the conductor material. It's the reciprocal of the resistivity. So sigma equal 1 over rho E. And of course we know rho E equal R A over L. So sigma equal L over R times A. So it's a measuring unit. The measuring unit of resistivity, ohm dot meter. So the measuring unit of conductivity, it's ohm negative 1 dot meter negative 1. Ohm negative 1 dot meter negative 1. But we need here another definition for conductivity. Due to it isn't satisfied for us to say it's only reciprocal of resistivity, but it's suitable for us to say that it's a reciprocal of the ohmic resistance of the conductor. If its length equal 1 meter and its cross section area equal 1 meter squared. This definition from is clear, it's from your mathematical rule here. Okay, as the conductivity is a characteristic, as the resistivity is the characteristic property of the matter, the conductivity will be a characteristic property of the matter too. Why? Due to it depends on the type of material and also the temperature of the conductor, due to it's a physical constant for the same material. We can recognize the material depending on the value of resistivity rho e or conductivity sigma. And as you see here, sigma inversely proportional with rho e, the resistivity. So sigma, the line between sigma and 1 over rho e will be straight line, passes by the original point. Here all the connecting wires will be made by the copper. Try to think after you're studying for these two concepts, resistivity and conductivity, why the scientist found that suitable to make the connecting wires of the electric circuit of the copper, not from any other material. This is due to that, of course, the resistivity of the copper is very small, which means that the resistance of the copper wire is very small. So as the resistivity decrease, of course the resistance will decrease due to R directly proportional with rho E, which is called resistivity, of course. That means the electric conductivity of copper is high. So it's used in making the electric transmission cables due to its conductivity is very large. So this means the collision will decrease as much as we can, of course, and the temperature will decrease, and this thing is very good. Now let's move to the next point to determine the resistance by using the mass and volume and the density. You know that R equal rho E L over A. Rho E L over A. But we need to calculate R by using the volume. How we can bond the volume? Of course, you know that volume equal L times L times L. L times L means area. So volume equal area times length. From here, area equal volume over length, and length equal volume over area. We can replace here area and put instead of it volume over L. Volume over L, here L in the third floor, so we can move it upward to the numerator, so it will be rho EL times L over volume, which will be here rho EL power 2 over volume. This is how we get this rule. But instead of it, we can put instead of L volume over L, because L equal volume over cross section area. So it will be rho E times volume over A, and we will find in the denominator another A. So R will be rho E volume over A squared. This is the second rule here. How we can put mass? You know that rho, the density, rho, not rho E. Rho E is called the resistivity. Rho is the density of the wire, of the mass. Rho equal mass over volume. So volume equal mass over rho. Volume equal mass over rho. So we can put here in this rule, instead of volume, we can put mass over rho. Rho is the denominator of the denominator in the third floor, so we can move it to the numerator, so it will be rho E L power 2 rho over mass. This is this rule. Or we can here in this law, we can replace the volume by volume equal rho equal mass over volume, so volume equal mass over rho. We can put here mass over rho, so this will be rho e mass, and in the numerator a squared rho. So these are the rules which you can use it to calculate the resistance in terms of mass and volume and density of the wire. Here, the last point in this slide, you can compare between two resistors of two conductors, R1 over R2, as you studied in math. If we will use this first one, rho EL over A, you have R1 and R2. R1 equal rho E1 L1 over A1, and R2 equal rho E2 L2 over A2. If you put R1 divide R2, we will put R1 rho E1 L1 over A1. Instead of divide, we will convert it to times, and we will oppose. We will put the reciprocal of the rule of R2, which will be A2 over rho E2 L2. So the rule will be rho E1 L1 A2 divide rho E2 L2 A1. By the same way, we can replace A. Instead of A, we can write by R squared. So the rule will be rho E1 L1 R2 power 2 divide rho E2 L2 R1 power 2, whereby we cancelled by from the numerator to the denominator. By this way, you can make the rules to calculate the comparison between two resistors by using the other rules which we talked about it before. Now let's move to discuss together a very important title, which is called the ways of connection, the ways of connections, the resistors. You studied before this point, but we will study this point together now in details. How we can connect the resistors or the ohmic resistance by two ways. We have here two ways. We have the first way, which is called series connection, and the second way, which is called parallel connection. We will study in details these two one. Now, number one, resistors connection in series. First, what is the purpose of this connection? The purpose of connecting these resistors together, obtaining big resistance from a group of small resistances. Why? Due to here, as you see here, R1 and R2 are connected together in series. This means the current I, which is produced from the battery, will pass through these two resistors, R1 and R2. R here is the same R there, so I here constant. So we can say that I1 equal I2 equal I. But V equal IR, and the value of R1 doesn't equal the value of R2. So the value of V1, of course, doesn't equal the value of V2. So V1 doesn't equal V2. V1 has a value and V2 has another value. So we can calculate V total. V total, of course, equal V1 plus V2. So we will replace V, it's I R dash. I R dash, R dash, this is called equivalent resistance. It's the total resistance equal V1 equal I1 R1. plus V2 equal I2R2. So I equal I1 equal I2. We can cancel all these i's together, and remains for us here R total equal R1 plus R2. So this is called the equivalent resistance. R equivalent equal R1 plus R2. If we said that R1 equal R2 equal the same value R1 equal R2 equal the same value R. So it's easier from saying that R equal R1 plus R2 to say R equal N times R. We will take only one value for R, and we will put, instead of summation of all these numbers together, you can put only the number of resistors. So here R dash will equal N times R. It will be in one case only, when the R's equal one value. So here, as you see, R equivalent, of course, more than all these values. So we obtained from small number of resistors a high equivalent resistance, and of course we can use it in a beneficial results. This is called the series connection. What about resistors connecting in parallel? In parallel connection, the purpose of this connection is obtaining a small resistance from connecting a group of big resistances. Here in parallel connection, as you see here, the value of I will divide on these branches in front of you, of course, so I isn't constant. But if I isn't constant, so V will be constant. V of all of these resistors will be constant. So V1 will equal V2 will equal V. But I equal I1 plus I2. I total equal I1 plus I2. So we will replace I. It will be V total over R total equal I1, which is equal V1 over R1, plus I2, which is equal V2 over R2. So we can cancel all these V's together because all the electric potential difference are equal. So here 1 over R dash 1 over R equivalent equal 1 over R1 plus 1 over R2. This means that R total will be R1 R2 over R1 plus R2. This is the R total here. This is the rule of R total. If R1 equal R2 equal the same value, it's better to say R total equal R over N. But you can't use this rule unless the values of all the resistors are equal. If all the values of the resistors are equal, this will make the rule R total equal R over N. But you can use R1 times R2 over R1 plus R2 if the values of the resistors are different. This the figure of connection in front of you. But now let me ask you a very important question. What do you prefer? To connect the appliances at home by a parallel way or a series way? You know that the purpose of connection, the series connection of the resistors to give high R equivalent, but parallel connection will produce low R equivalent. So which is better from your point of view? Of course, it's better to decrease the value of R, because decreasing the value of R will help us to protect the electric energy. So home appliances are connected in parallel. Thus, every device can work individually on the potential difference of the source and doesn't affect the other device. when switched off, although their equivalent resistance becomes very small and doesn't weaken the electric current intensity. Okay, this is why we prefer to connect the devices at home in parallel connection. Next important question here. Imagine with me you are connecting here two resistors in front of you, parallel connection. You have here beside ammeter 1 and ammeter 2 two connecting wires, and here on this branch the source of the electric current. We have here another part of the connecting wires. Try to think which one of these we have to make its cross-section area is large and which one its cross-section area is small. Try to think with me, and why you need to make it large or small cross-section area. Try to search by using your mind and try to decide which wire should make its cross-section area large and which one we need to make its cross-section area small. I will give you chance to think.